Then we'll discuss more about this. So you can see the hand motions. So how precisely it can cook, like the data which you fed into it. So this is one application of robotics. So the second one is the industrial robot, which I'll show you. So this is the robot from Fanuc. It's very, a prestigious company which delivered many robots for the automation. So this is one of the factory in Germany for Audi. So you can see the application of the robot here also. So these are the serial robots. I guess you might have seen such robots. And you can see the function, the operations of these robots, how these robots collaborate with each other and how they are programmed to do a certain task. Like here you can see the assembly of the engine. Right. So here you can see, so when you take this, like the robotics lecture or robotic coursework, you learn these, how to program this manipulation, how to design such kind of robot, how to do the path planning and all. Right. So you can see how precisely these robots move on it, and you can see the payload also. For an individual, it's very difficult to move, to have such kind of motions with this much payload, right? Okay, so here this is a conventional surgery of the gallbladder. So I'll start with the surgical robots. So here you can see the surgical operations to remove the gallbladder from the stone. Like this operation, the surgeon used to perform like 10-12 years ago. So you can see the incision which he makes to remove the stone. So he first he put so much long incision, and then with the bare hand they used to remove. So you can see the lot of risk and a lot of blood loss and lot of time taking for the surgeon as well as the patient also. So this is the standard operation which used to be performed like 10-12 years ago. Now after that, recently, like 5 years back, so the people used to, so the surgeon used to perform the laparoscopic surgery. In this, so this is also for the same gallbladder surgery to remove the stone from the gallbladder. So what they do, they put a very small stitches, like 4 incisions they put. You can see the size of the incision here. And then they put a trocar here. So this is the trocar which they put, and after that they'll insert a tool inside to operate, to have the maneuver. But still here the doctor operates with the hand, so if there is a fatigue, so this is a tool to hold or to grasp something. So manually the doctor used to perform this, but here you can see this incision is not big. So here the recovery time for the patient will be more. And then we'll see this robotic surgery. So this is teleoperated surgery. So you can see the doctor is sitting somewhere else and his hand motion is transferred to the robot. Right. So this is the end effector, what we call the tool. And we'll discuss more about this. So you can see that surgeon is sitting there somewhere else and patient is here, and these arms are performing the operation. So the hand motion of the robot, the surgeon, is transferred to these arms, right? So this is the dexterity of the tool which goes inside the body. So you can see how beautifully the manipulation, the movement, the hand motion of the surgeon is transferred to the end tool, which is in the first part of the video. Okay, we'll see more about these kind of robots. So the traditional surgery which we have seen like 2 slides back, where they have put the big incision, is what operate manual and instrumental techniques to treat the pathological condition, as we have seen in that the gallbladder, to remove the stone of the gallbladder surgery. After that, the laparoscopic and robotic surgery comes into the picture. So these instrumentation is what is the machine with AI, the artificial intelligence, right? And we'll see the different component of these machines. So as you have seen the robotic surgery, so I'll on the pointer. So robot assisted surgery allows doctor to perform many types of complex procedures with more precision, flexibility and control than is possible with conventional technique. So most widely used robotic surgical system includes a camera arm. So here you can see 4 arms, right? These are the 4 arms. So one of the arm contains the camera, the endoscopic camera. And so the live images of these camera you can see in this screen and here the computer console. Okay. So the computer console gives the surgeon a high definition magnified 3D view of the surgical site that is inside the patient's body. Okay. So here you have 3 different arms. So we'll see more about this structure. So the first part is the patient cart. So here is the patient cart and you can see the 4 arms, right? And one is, so this is the endoscope, this is the camera, right? And these 3 are the arms, different arm. So in the video you have seen the surgeon used to move some like the robotic structure. So the 2 arms is associated with a surgeon and there is option of another arm which is used to assist, you know, a big surgery, kind of surgery. So there is assistance also. So the mobile unit is positioned beside the patient and supports the central camera arm and 3 instruments arm which are numbered 1 to 3. So here you can see these are the tools which is used while doing the surgery. So one can replace this based on the surgery which is like taking place. Okay, so this is very easy to remove. So assistive nurse is there to remove this tool. So this is the tool. So this is the tool which can be replaced from the existing ones, right? So the camera is inserted into the central camera arm and the selective operative instrument can be inserted through instrument arm 1, 2 and 3. Okay, so there is another vision card. So it's very important. Now you can imagine surgeon is sitting somewhere else. Now it's very important for surgeon to have a 3D view because depth is also important. You can imagine while doing surgery, if he don't have the depth information, he may cut somewhere else or he can make a tremendous mistake. So there is a very good 3D replication of the image and parallelly other people, other assistive surgeons like or the nurses also can see the live images in the screen. So we call that as a vision card. So let's now discuss about the surgeon console where the surgeon sits. So the surgeon sits at the surgeon console and views the operative field through a high definition image visor, right? So this is the image visor, or you can see here, from here he can have like a 3D view of the inside the patient's body. Right. Switches on the left side of the surgeon console control ergonomic adjustment of the image visor, arm board, and foot pedals to maximize surgeon comfort. A selection screen on the arm board allows for adjustment to a variety of system parameters, that is audio, video, and mechanical. The surgeon console includes the hand control and foot pedals, which give surgeon complete control over the camera and instrument while performing the surgical task. So here you can see. So these are the power control and ergonomic controls, and this the left and right hand control. This is where from where the hand motions of the surgeon is transferred. So these arms have encoders and sensors which takes the live position of the surgeon hand. So what is the benefit for these kind of surgery? So in the first video you have seen the stitches, right? 1 second. So you see a very big stitches they make for performing any surgery. Then in laparoscopic surgery, they put a 4 small incision, but still they are moving with the hand. Like if the surgery is for long hours, so there may be fatigue with the doctor, and maybe the hand motion can be transferred to that surgery, and there may be some casualties. So in case of robotic surgery, surgeon can sit comfortably and do the operation. So faster recovery time and return to the normal activities, smaller incision result in reducing risk of infection, reduce blood loss and transfusion as there is very small stitches. So there is very less blood loss. So no risk of transmission of disease as there is no big incision. So a disease can be, stopped from transmitting inside the body of like the patient. And shorter hospitalization. So this is very important for the developing nation, where there is a lot of load is there on the hospital and very few beds are available. So this is the main factor why a developing country should opt for these kind of surgical systems. And then there is a reduced pain and discomfort as there is a less incision and there is minimal scarring. So what is the benefit to the surgeon? So greater visualization or immersive view through the tiny incision, as there is a very good 3D image of the organs. So he can visualize very finely and then enhance dexterity. So his hand, now he has a very good space to move his hand and relax a bit. And there is a greater precision as it is, the motion is transferred electronically. So we can remove the tremor and other things while with the algorithms, with the standard AI algorithms. So easier to attach nerve endings, no risk of transmission of disease. So like in this kind of era, corona and all. So a surgeon, you can imagine a surgeon can sit somewhere else. So he need not to come in contact with the patient. So he has also, there is no risk for him for the transmission of disease. And reduce of surgeon fatigue. He don't have to stand for such a long time. He can sit and operate very comfortably. So the video which we have seen is from DaVINCI. So this is the only marketable surgical system which is there in India also. So in this video, you can see the newer version which is yet to come in the market. Now here you can see there is only one trocar. So there are 4 arms. Now here there is only 1 arm. So only 1 incision is needed here. And you can see this flexible kind of arms, snake-like robots are coming out of it, right? So this is the new version. So here camera is there and here 3 arms is there. So still it has, so it's FDA approved and yet to come in the market. So this is the latest version of the surgical system. And so there are other worldwide manufacturers are there, but they are not very popular due to the cost and the design of the scheme. So one is the CMR surgical system. So few hospitals, I guess in India, they have this now, CMR surgical system. So there is endoscopy E200. So these are not full-fledged for the robotic, the surgical, like a surgical robot. So it's for a specific task. And there is flex robotic system and then core path. So we'll see this system. So it's very specific. So it's for very specific kind of surgeries. And then you have new guide colonoscope. So these are the systems now, which is not FDA approved, but still in the research phase. So one is K-Flex from KAIST University, South Korea. Still people are developing this system. And then Titan from the Titan Medicals from Canada. And again, this is from South Korea. And this is SurgiBot from US. So a lot of people are doing a lot of research in developing these kind of systems. So if we talk about the Indian market, so there are 300 active surgeons in India performing operations every quarter using the DaVinci surgical system, which we have seen at Fortis, AIMS, Apollo, Columbia Asia, and Tata Memorial. So if we talk about the world market, so by 2023 there will be like 6.5 billion of investment in only the surgical system, and India is also a very big market because a lot of users are there and there are a lot of patients are there for to perform these kind of surgeries. So the 3rd and 4th generation of DaVinci surgical system, which we have seen in the video, like the first video is there. So the cost of this system is like $1 million and $2 million. And yet the final one which we have seen is more than 3 or 4 million. Now you can imagine the cost. So why India should, put a lot of money in the research to have such system? Because if you see the real cost, it's very less, but they are only the player in the market, so the cost is very high. So 70 systems setup is there, and these DaVinci surgical system, they have a mobile van. They have installed this robot in a van. So for example, if you ask for the demo, so they can send their van, and you can have very, very good demo of their robotic surgical system. And now we have seen like CMR surgical system. So in Galaxy Care Hospital in Pune, they have the first. That is the first hospital to have the CMR surgical system, to procure this system. Okay. So if we conclude, like for this surgical system, so why it is important? So you have small incision, fewer stitches, faster recovery and less pain, resume normal activity faster, shorter hospital stay and lower cost, minimal blood loss, and smaller skin scar. So due to these features, from traditional to laparoscopy to robotic surgery, why we are going towards that. And if you imagine also, if you think more of also, very less expertise are there. So as the structure, you can see surgeon sit somewhere else. So he may be in Canada, and this system may be in India, right? So he can operate directly from here. So the travel time for this expert may be saved, and critical surgeries can be done teleoperatively. So this is the beauty of these kind of systems. Right. So I'll talk a little bit about what we are doing here at CSIO. So CSIO is a research lab. So you can visit the site csio.res.in to see the ongoing research activity. So we are instrumentation lab. So we have also developed one surgical system. So I'll show you that. So in first image, you can see the handle, surgeon handle. So this is the surgeon handle. So I'll show you the video also to have good visualization of this image. So this is the tool end, the arm, and then I'll directly go here. So you can see this. So in DaVinci, you have seen the forearm. So for the display, I'm showing you only the one arm, right? And this is the tool which is developed here. And now I'll show you the video. So this is the video. So you can see, as in the DaVinci you have seen. So this is to capture the motion of the surgeon or the user. Right. So you can see very precisely the motion of hand, can be transferred, can be stored. So he's writing 2, and you can see in the screen there is a 2. So there are encoders in the sensors which have the real-time position of the hand. So this is all about the kinematics of a surgical system. Right. So this is the tool, and we can see that. So you can see with the hand motion. So this is teleoperation. Because the handle is downward, so you can see the reverse motion here. So this is the demo for that. So it is operated from here. Right. So this is the system which is developed here at CSIO. So we'll see. So there is another robot which is for the catheterization. So cardiac catheterization is minimally invasive surgical procedure used to diagnose and treat the certain cardiovascular conditions. So you may have heard about the heart attack and blockage of the vein in the heart, right? It's very common nowadays in India. So previously what doctor used to do, they have to, you know, open up the heart and they have to perform the surgery. But now what they do, they put, like I will show you. You will be placed on a table. So you'll see the procedure now, what they do to remove such kind of clot from the heart. So they don't open up, like they don't put much incision, rather they use this vein in the thigh. So this is the biggest vein. So this procedure involves inserting a thin tube-like structure called catheter into the blood vessel, right? So you can see the motion of the catheter, and when the catheter reaches here, so depending upon the procedure, the catheter is moved in different regions of the heart. So this is the standard procedure now. The surgeon used to do the catheterization, right? So this is the real-time image. Yeah, I'll show you from here. So this is the real-time image from the X-ray, so that doctor may know where the catheter is, the current location of the catheter. So here the risk for the surgeon is, he has, again when he stands there, see he has exposure of X-ray. So what doctor wants, they want to sit somewhere else and they want to operate this catheter. So we received this problem statement from AIMS. So the doctor wants a surgical system to have the 2 degrees of freedom of motion of catheter from the teleoperated areas. So we have developed like this system. So here so this is the developed system. So here the challenge is, you know, so this is the catheter, right? So this is connected with a transducer to measure the pressure inside the vein. So there should not be any deformation on the catheter. Okay. So the challenge here is, so when you move this rollers, so the frictional force should be such that there should not be any deformation here in the catheter. So it is very important to model such that this force from the spring should be such that it should move this catheter but not compress this catheter. So this is for the translation motion, and then this system is for the rotational motion. So I will show you the video. So the motion is something like this. So this is the one project which we are doing now. So you can see this is the spring. So why mathematical modeling of such kind of system is very much important, you know. So we use different tools, like to know the force on this catheter, we use ANSYS to know the stress and all information. And there are some softwares to design such system. Right? Okay, so we'll stop that and we'll see some other robot. So this is the aerial robot. So you may have heard a lot about the drones and all. So there is a company Festo from Germany. So they used to make biomimic. The biomimic. So this is a bird kind of robot. So you can see how it flies. Again, there are a lot of applications of such kind of robot in like the agriculture field or for the surveillance for defense. So you can see the mobility of these robots. So again, here you have actuators. Again, you have to write certain codes. You have to design the kinematics. Again, the basic one. So what they do, they first observe the bird, the real time, the motion of the bird. They capture the motion and then they translate it into this small bird kind of robot. Okay. So you can see the site of Festo. There are a lot of other robots also. Due to time constraint, I just put this, to have certain ideas. Now this is again a drone kind of robot. So this robot delivered the medicines in Tanzania. So you may be heard of the Amazon. Now they are putting some drones for delivering of the product from their warehouse, and then Uber Eats they are also using. Now they got approval for that. So these are the some application of the drones. So these all are the aerial robots, the aerial vehicle. So again here all the kinematics concept, everything is same again, but here you have to take a GPS data or the data from some other sensors like the accelerometers and all to have real time position of these aerial robots. So they fed the location. So this drone goes to the target location and delivers the medicine. So again, the design depends on the payload and everything. So a lot of depending upon the application, the design methodology changes. So seeing such kind of remote locations, there is transfer of the systems. So there, so you can see this is the real-time location. Yeah. So this is in the remote location they used to send these drones to lot of applications are there. So this is the application of the drones. Okay, so now let's discuss a little bit about, so you have seen a lot of robots, right? So let's talk a little bit about what to study in in your courses to get to design such kind of systems or to realize this kind of the robotic architecture systems. So we'll take an example. So this is a Orthoglide. So you can see, so this robot can be used, this manipulator can be used for different applications, for milling or 3D printing. You can visualize any n number of applications for that. So here, if you see, so there is one actuator, linear actuator is here. There is one actuator here and one actuator on the top, right? So let's say if this is x-axis, y-axis, and there is one here in the z-axis. So these three actuators linked with this end effector. We called this as an end effector, right? So we'll see first how to model this kind of systems and then how to start with the design mathematical modeling, right? So let's see, this is a very simple mathematical model of this system, right? So this A1, B1 is this actuator here. And then A2, B2 is this actuator on the y-axis, and then A3, B3 is on the z-axis, right? So this is moving. So we have, and this P is the end effector, right? So let's say the X, Y, Z. For example, in drones, the location, like the orientation and everything is nothing but, so what we can do, we can give the position of this end effector depending upon the end effector type. So suppose if you have any rigid body, so you have how many degrees of freedom for that? So you have like X, Y. So for example, if there is a duster, right? So how you can define this duster mathematically in three-dimensional space? So you should have X, Y, Z, and then the rotations across all the axes, right? So let's say alpha, beta, and gamma. So here we don't have rotation, so we'll take only this X, Y, Z to move in that plane. So the first step in defining such model is to write the constant equations, right? So how to write the constant equation? So this point P, we know that it's XYZ. This is X-axis, right? This is Y-axis, and this is Z-axis, right? We place these three actuators here. Now you should always see what is the constant, like the constant of your mechanism. So how mathematically you can put these equations. So for example, if I say this is the variable length, right? So let's say this is rho. Okay, so this changes, but A1 will never change, right? Because it is fixed. So if you know the position of B1, you can able to write B1P. Again, this length is fixed, right? So this is L, capital L. So if I know the coordinates of B1 and P, I know it's XYZ. So I can write certain equations, right? So if you visualize this B1, it's on the x-axis, right? So I can write this B as rho1, 0, and 0, right? So this rho1 is what? This is the actuator length which is moving. So here you can see this is the rho1. Okay. So when you open this, so you'll get three equations. Okay. So you have 2 points, this point and this point. So if you remember the 3D geometry, so the distance between point is nothing but the root of if you have to do the subtraction, that is x1 minus x2 whole square plus y1 minus y2 whole square plus z1 minus z2 whole square. So we square these and we'll get these three equations. Now these three equations we called as a constant equation, right? So if you see this equation, you have x, y, and z, and then this length L, you know, right? This is a fixed length. What we don't know? We don't know the x, y, z, and this row. These rows. Okay, so this is all about robotics, to measure these values. So in one instance, you know this rho1, rho2, rho3, you have to solve these equations to get x, y, z, right? In one instance, you know x, y, z, and you have to compute this rho1, rho2, and rho3. So this is all about the robotics. So here, suppose, so why it is important? Now you imagine if I know this row location, rho1, this row, and this row. So easily, if I put these values here, I can get the location of this end effector. Okay. So so to visualize, to understand a little bit, so I'll not go in much detail, just to summarize that. So we have x rho n. So this is the constant set of constant equations. This is pose variable, right? And this is rho, what we have seen, the actuator length. So we called this as a pose variable, this as articular variable, right, which is actuating. So this may be, as there is a linear actuator, so we call this as a linear, like the rows. So if there is a rotational normal motor, we call this alpha, beta, and gamma, right? So the angles will take. So there is a workspace. So workspace of the robot. So workspace is nothing but set of all the values of this x, y, and z, right? If you plot all the possible values of x, y, z, you will get the workspace. If you plot all the possible values of these rows, you will get the joint space. Okay. So if the pose variable is given and then you substitute this pose variable in this f, x, and rho, so you'll get the joint variables, right? We call this problem as the inverse kinematic problem. So this is the one problem which you deal with if you're designing any kind of surgical or robotic system, right? So when you solve these equations, these are the algebraic equations, right? You won't get only one number of solutions. So you'll get different number of solutions. We call that as a working modes. So these are the standard terminology which when you refer the papers and all, you'll find these words. So this is nothing but the number of solutions, right? If you get 2 solutions, 4 solutions, so one can visualize or understand the different parameters associated with this working modes, right? So similarly, if the joint space, the joint variables, that is, if you know the rows value, the actuator values, and when you solve for the pose variables, that is x, y, z, we call that as a direct kinematic problem. So these two are the two standard problems in the kinematics. So we are talking still about the static analysis, right? We are not discussing about the dynamics. So the difference in the dynamics is when you take the velocities, right? We are taking up what? The actuator positions, the rows and x. So when you take x dot and rho dot, that is the, if you map the velocities of the joint variables to the pose variables, becomes in, so the dynamic picture comes in, and we have to do a lot of analysis in that. So this is the two major thing what you have to do before manufacturing your robot, right? So this is what you learned in the first part of your robotics course, the kinematics, the inverse kinematics and the direct kinematics. Okay, so this is all about, we'll not go in dynamics. So okay. Now after defining all this, now you can imagine these are the mathematical equations, right? So sometimes what happens, you won't get any solution on that particular point or on that particular joint variable. At that situation, so that your robotic system won't know where to go at that point. So we call that as a singularities, right? So there is a word for this, singularities. It's nothing but when you don't have any solution for your system. Okay, so your robot won't know where to go. So physically, if you see, the stiffness of any system, robotic system, will go away. So it's very important to learn this, to know these singularities when you design any kind of robots. Okay, so that is about the robotics. So we'll see a little bit about the artificial intelligence in the healthcare system. So you may have heard about this artificial intelligence many times. So all the people, they are talking now about these systems. If you see the retail system, Amazon or any sites, also you have a chat bot there. They don't have people now. So with this, algorithms, the artificial intelligence, one can mimic the intelligence of the human, like the human being. So if you see we'll see some examples in the healthcare part, how these artificial intelligence help to diagnose certain kind of disease, which previously was very difficult to do. So this is the CT scan images. So previously what us expert doctor used to see these images, and if there is some irregularities or something, so he used to diagnose the disease. But with this artificial intelligence thing, so a system can scan all these images, right? And if there is very minute or any changes is there, it automatically pop-ups and tell, okay, there is a problem. So now you can see how very beautifully we can use the expertise of the expert in the field, because we have very less expert who can translate these kind of images. So this is the example in the dermatology. So this is very common. So there is a scar. Now to diagnose this, because it may be linked with the cancer and all tumor, this kind of tumors. So with the visual eye, it's very difficult to see and to diagnose anything, right? So if you have, imagine the system, AI system, you sit in front of that camera, so that will tell you, okay, so you have to be very careful about this, because the size changes, and so there may be different, from the expert you can get different parameters to know about these details. So again, this is another branch, ophthalmology. So here you can see the retinal images. So this is very, nowadays many people, Google also, they put a lot of money in researching this. So with these images, one can diagnose whether the person is diabetic or not. So there are standard algorithms and people are doing that. So with very simple images, one can see and tell, okay, so there is a risk of diabetes and all with these images, again, thanks to the artificial intelligence. So this is again the pathology. So when you go for the blood test and all, so physically a nurse or a technician, they used to see, count and do all the jobs. But now with the standard algorithms, AI algorithms, one can again see different kind of, you know, these image. So these images, they can, so the AI algorithm can scan these images and tell if there is any problem exist. So again, clinical outcome prediction. Now there are, you know, certain devices which is, so we'll see this in here. So there are a lot of wearable devices are there. So you may have heard about the Apple watches and all. Now they come with SpO2 and pulse details, right? They monitor for whole day. They will monitor and they'll diagnose something. They'll tell, okay, now you need to work, or you have to take care of this. So these kind of devices again equipped with AI algorithm to, and you can transfer these details to the, you know, your physician also, so he can check and he can diagnose whether you have to take care of anything or not. So these are, you know, some applications of the AI. Okay, so thank you for listening. So we can discuss, we can take some questions.
Okay, students, now the platform is open for your question answers. If you have any, you want to ask any question, you can directly ask, or you can type your question in the question chat box.
Yes, or my mail is there. You can, if you have any queries, surely you can send. So I will share a link also. So if someone interested, they can go. So there is a call for training in CSIO. So one can search here for the, like, for the new graduate students.
Okay, this is the useful information, students. We are getting that there is a need for a requirement of a trainee in the CSIO. And if you are interested in this, you can visit this website and you can get more information regarding this.
Yeah. So there are different fields. So there is instrumentation, there are optical instrumentation, then agree based on sensors. So there are a lot of different fields. You can find on the website of CSIO all the details.
Okay. So the first question is from my side only. So as I said that I have given you a formal introduction, but
Yeah.
I would like you to share your experience of your professional journey as in your own words. So if you throw some light on your selection, how you selected all this path till the CSIO. If you share this information with the students, this will be definitely helpful to carve their path in their career.
Yeah, sure. So, so after graduation, like after bachelor's, so I have joined here at CSIO as a scientist trainee. So it's short of 2 years of training, but then there is a academy also of CSIR. So we have received the masters from there. So there I was working on the surgical robots. So we didn't have a lot of expertise on the kinematics, mathematical modeling on that, but we were very good at, you know, instrumentation part. So still we were struggling about the kinematics, mathematical modeling and everything. So what I faced. So after that I have applied for PhD outside. So I'll share, you know, in the chat box. One can see the different scheme. So there is a scheme called Erasmus Mundus. It's for the European countries. Okay, so you can go through the links. So this is the fellowship given by the European government. I'll share my email ID also. If you are interested in doing like a research kind of work or your masters from Europe, so you can always search for Erasmus Mundus fellowship. So once you get the fellowship, you can select any institute. So this is the beauty of this like the fellowship, and this is tax free. So this is for the European countries. Then if we talk about the UK and all, so there is something called Commonwealth.
Yeah.
Commonwealth fellowship, right? So if you are interested in doing this, so it's always good, you know, how, so first try to see the research work at their institute, and then try to start communicating with that professor. So share your ideas, share your like chat with them, and then you can ask for these fellowships. So you just tell that I want to apply for this fellowship, and you can get a recommendation letter from them. to apply for this fellowship. It all depends upon your interest. So where what you want to do. Again, in the US, so if you want to do from US or Australia side, so there is no such kind of pre-fellowship. So after applying from the universities, you like after getting the confirmation for the admission, then you can apply for certain like certain fellowship. So it's from either from the university or from the professor. They have some project, so they can fund your like the thesis and all. Okay. And so if we talk about here in India, so still there is for PhD, I don't know for the masters if there is any fellowship. For PhD, there is one PM fellowship. It's very good fellowship. So if you want to contribute in the industry, so you can go for this PM fellowship. Right. So what I suggest, so first find out your interest, where your interest is, and then try to search different options. And then you have, a lot of platform is there in the Google search. You can search for that particular area and then just add the word fellowship in that and then start applying that. So the interest is very important.
So, sir, to join the CSIR like institutes, is there any need to that you should have a good scoring gate or like thing, something like that, or
No, so
without it you can apply for the this any courses?
okay, so it depends. Like the for the students, like the graduate students, for doing the training and all, so you can directly apply to the site. But to join as a scientist, so it's a central government organization. So there is a standard call for that, based on the advertisement on the newspaper, and again the qualification is very basic as per the government mandate. So it's only the masters with 2 years of experience, and there is only fixed cutoff is there 60%. So all depends upon the
Oh,
interview process. And for the PhD and like the masters, there is another course called IDPP. It's masters plus PhD course here in CSIO. So for that, there is, if you have a gate or net score, so you can get easily in such courses, the admission in such courses.
okay.
I can share that link also. This is for the masters and PhD. So someone asked how we can come to CSR after graduation. So now, like so previously, like 10-15 years back, so there was like the position of a scientist B, but now they have closed. So after masters only you can apply in CSI or any CSIR lab.
Okay. Yes, students, if you have any more questions? I guess no more questions, sir.
Yeah.
And yes, sir. Today's session has certainly given a different insight to the students regarding the robotics and AI. Now we see many good applications of robotics, uh, for the design and development, how the mathematical modeling is important. This session particularly also focuses in that direction, and I guess the majority of the research is done based on the mathematical modeling of the different types of robots. And so I think today's session will give different insight to the students and for their career selection also. And because we know that most of the students, they are going to the mainstream of corporate job after completing the BTech. But the student can think about this different trend that will be emerging in the next few years, because now the more focus is on the research as compared to the this corporate based or industry based jobs, where the Initially there were the machines which were operated by the humans, but because of the automation, that work is completely getting eliminated, and most of the work that the engineers will have to do is in the field of research, I guess. So I'm thankful to you also. I extend my sincere thanks to you for sharing this information and guiding the students for the future options. I'm thankful to Dr. Santosh Sonone also for supporting in organization of this session. A special thanks to our faculty members, Yogendra Jain and Rishikesh Kulkarni. And also I appreciate the participation of the students. Thank you, sir. Thank you for giving your valuable time and sharing this information.
Thank you, ma'am.
Yeah. Okay, we will end the meeting now.
Okay, thank you, everyone.
Thank you, sir.
Thank you, sir.